So in continuation with the last lecture about PLC architecture, we also explored the input devices like switch. Okay, so in this lecture, we are going to discuss about what are the various types of switch available in the PLC. Okay, so there are the switches broadly categorized as two types. One is manually operated switch, another one is a mechanically operated switch. Okay, so in this lecture, we are going to explore what is a manually operated switch. Okay, so manually operated switch is nothing but the push buttons. Okay, and mechanically operated switch are nothing but the limit switch. Okay, so this mechanically operated switch are used for different type of sensors. Okay, so those things we'll be exploring in this lecture. In addition to this, we are going to explore some of the concepts behind the ladder program like latching relay, sequential relay, interlock circuits, and how we are going to program the latching relay, how we are going to program the interlock circuit as well as a sequential logic circuits. Coming to the first two category of switch, one is a manually operated switch. From the word itself, it is very clear that it is a manual means which is controlled by means of a hand. Okay, so this includes a toggle switches, push button switches, knife switch and selector switch. Okay, so the main important switch we are going to discuss under manual switch is push button switch and selector switch. Okay, so this push button switch, okay, so most common form of manual switch, manual control. So it operates by opening and closing contact when pressed. Okay, so commonly used push button switches are normally open, normally closed switch, and break before make push button. Okay, so normally open switch means it makes a circuit when it is pressed and returns to its open position when the button is released. This is normally closed means it opens the circuit when it is pressed and return to the closed position when the button is released. Another one is a break make push button switch. Okay, so it is going to have a top section contacts are normally closed and the bottom section contacts are normally open. Okay, so when the button is pressed, top contact open before the bottom contacts are closed. Okay, so this is about the manually operated switch. So these are the representations of normally operated switch. There are two type of representation. One is a IEC symbol, another one is a NEMA, that is National Electrical Manufacturing Association symbol. So representing a normally open switch. Okay, so usually we'll represent NEMA switch also. So here you can see that normally open switch will have a setup like this, and similarly this is also normally open contact. Here you have like a setup which represents the push button. Okay, another one is a normally closed switch. Okay, so you can see that there is a the contact is closed. Okay, so here also in the IEC symbol the contact is closed. Okay, so this is some switch represented in the industrial standard. Okay, and similarly brake make switch, will have both the open and closed contact. Okay, so any one will be activated at one time. Okay, so these are the commonly used types of push button switches. Okay, in addition to this there is also a three position selector switch where it is going to have a three position, both the manual and auto. Another one is a on position and off position. Okay, so position one, it moves to the contactor A. Another one position two, neither A nor B, and position three it is moved to the contactor B. Okay, another one is a dip switch. Okay, that is dual in package switch. So it is going to have as a on and off. Okay, so one contact is off, another contact is open. Okay, so these and all coming under the different forms of representing the push button, which comes under the manual switch. So coming to the next type of category of the switch, another one is a mechanically operated switch. Okay, so the mechanically operated switch is controlled automatically by a factor such as pressure, position or temperature. Okay, so the most common switch is a limit switch. Okay, as we see a most common switch in the manual manually operated is a push button. Here we use a limit switch. Okay, it is a very common industrial control device. This limit switch are designed to operate only when a predefined limit is reached. They usually are actuated by contact with an object such as cam. Okay, so these devices takes the place of human operator. They are often used in a control circuit or machines or process to govern the start, stop, or reversal of motors. Okay, so we have a different type of switch which is opened and closed by means of several factors like pressure, position, or temperature. Okay, so in the next slide we are going to explore about the temperature switch. So as we said that mechanically operated limit switch is operated by means of a cam, okay, cam on a machine, and there is an operator and there is an enclosure containing a contact mechanism, and when there is operating forces there, it is going to open or close, I mean on or off. Okay, so here it represents a normally open limit switch. Okay, so this is open limit switch and this is closed limit switch as per NEMA symbol, and similarly as per IEC symbol also we represent the normally open and normally closed switch represented using a mechanically operated limit switch. So here it is representing a temperature switch. Okay, so it is a programmable thermostat which is going to represent what is the temperature, right? So the temperature switch open and close when designated temperature is reached. Okay, so as we know that in several industrial applications we use a desired temperature, the range of air, gas, liquid or solid. Okay, so we want to measure the temperature of air or gas or liquid or solids. In that case, it is mandatory to use a switch which is a programmable thermostat. Okay, so if you represent the temperature switch, you are as per the NEMA symbol, it is going to have a normally open contact with representing this symbol representing a temperature, and similarly this is a normally closed contact. This symbol represents the temperature, and similarly as per the IEA standard they represent there is a the switch normally open contact with be represented with a switch like this and normally closed contact with this contact. Okay, so this is about the temperature switch. So moving to the pressure switch. Okay, so the pressure switch it is used to control the pressure of liquid or gas. So it is mandatory like similar to a temperature. Here also it is mandatory. We need to measure the pressure of liquid and gases. Okay, although many different types are available, basically designed to actuate, open or close their contact when specified pressure is reached. Okay, the pressure switches can be pneumatically or hydraulically operated switch. If it is a air, it is pneumatically operated. If it is a liquid, it is hydraulically operated. So generally bellows or diaphragm presses up against the small micro switch and causing it to open or close. Okay, so this is a switch representing a pressure. Okay, so you can see here as per the NEMA standard, as per the IEC standard. So NEMA standard, so you have some stump. Okay, so some part which is representing the closure of the pressure. Okay, closure of switch based on the pressure. Okay, so this is a switch representing based on the IEC symbols. Okay, so these are the pressure switches. And next type of switch is the float type level switch. Okay, so you know very well the float type level switch is nothing but a float is attached to the float is nothing but a weight is attached so that the liquid rises the switch float and turns upside down actuating the internal contact. Okay, so you can represent as per the NEMA standard, you represent that there is a ball representing the float attached, so which is representing the level switch. Okay, this is normally closed to contact and this is normally open contact representing the float type level switch. Okay, so next we are moving to the next type is latching relay. Okay, so latching relay is nothing but assuming that there is a motor and there is a switch which is used to on the motor. Okay, so even if you remove the power supply, okay, the motor keep on running, it will get it will get off unless and until we press the stop switch. Okay, why the matter is keep on running? It is because of the latching relay. Okay, so what is this latching relay? The electromagnetic latching relay are designed to hold the relay closed after the power has been removed from the coil. Okay, so even if you remove the switch, okay, if you remove the switch, it keep on running because it is this relay is there. It is going to hold the relay closed after even the power has been removed. Okay, so latching relays are used when it is necessary for contacts to stay open or closed even though the coil is energized only momentarily. Okay, so this shows a latching relay that uses a two coil. One is a latch coil that is momentarily energized to set the latch and holds the relay in a latched position. Okay, so you can see here there is a start and there is a stop switch and there is a motor starter coil. Okay, so this motor starter coil we are going to have that as a latch coil parallel to the start. Okay, so even if you remove the start switch, it keep on running, okay, unless and until we press the stop switch. Okay, so the unlatch or release coil is momentary. Okay, so this is the concept behind the latching. So another practical application of relay logic is interlock. Okay, what is this interlock? Okay, so where it is required that two incompatible events that should not occur at the same time. For example, you have a motor can run in a forward direction as well as it can move in a reverse direction. Okay, but both should not happen in the same time. Okay, so to overcome this we are going for an interlock circuit. Okay, where two motor contacts are wired to switch the polarity to an electric motor, where the forward and reverse contact should not be energized simultaneously. Okay, when a contactor M1 is energized, the phases are connected directly to the terminals of the motor. However, when M2 is energized, okay, so phases are getting reversed. Okay, so you can see that there are three phases of a motor here, which is connected with M1. Another case it is connected to the M2. Okay, so if it is connected with M1, it will makes the motor to run in a forward direction. Okay, and if you see that if uh, if it is connected to M2, you can see that it should the motor should move in a reverse direction, but the interlocking is going to ensure that both the operation is not going to done on a same time. Okay, so it is going to either spin in a forward direction or in a reverse direction as per the connection. Okay, so here you can see that we have a normally open switch. Okay, so you have a for forward direction one switch and M1 get energized, and for reverse direction another switch M2 get energized. Okay, so the normally closed open loop contact when which is thermal overload contact, it is activated by the heater element. It is a wire in series with each phase of AC motor. If the motor gets too hot, the contact will change from its normal state to open state, which will prevent either contacting from energizing. And similarly, if someone wants to do the phases in A and B would be short circuit together by virtue of factor M1 sensor phases A and the contactor M2 reverses them. Phase A would be shorted to phase B and vice versa. Okay, and to prevent this happening, we are going to have some interlocking. Okay, so interlocking in the sense during forward only M1 should get energized and meanwhile M2 get off close. Okay, and similarly during reverse M1 get is off and only M2 get energized. Okay, so to prevent this data, okay, in order to prevent this interlocking, in order to prevent the contactor getting energized and de-energized simultaneously. Okay, so that should not happen. That is going to affect the motor. So to overcome this, we go for a interlocking. Okay, when M1 is energized, normally closed accelerator contact on second rung will be open, thus preventing M2 being energized even if reverse push button is actuated. Similarly, if M1 is energized, station is prevented when M1 is energized. Okay, so this is the concept behind the interlocks. Moving to the sequential relay, it is very important that in a factory or a industries there are a lot of loads are there. If we are making all the load to run at the same time, it is going to have a more power consumption. To overcome that, we can go for a sequential motor control where, assuming there are three motors are there, we are making the motor one to get on, and after some time delay motor 2 will get on, and after time delay motor 3 will get on. Okay, one after another, that is in a sequential operation in order to reduce the power supply. Okay, so that is called as a sequential relay. Okay, so in this case, we have to operate a three motor sequentially. There are three motors to be controlled in a sequence, so that the motor will start sequentially. Say motor 1 will start after some delay, then motor 2 will start, and after some delay, motor 3 will start. Okay, so each one will have a 10 seconds to start all motors in a sequence. Okay, so how we are going to do this program? Okay, there is a cycle on and motor one on. Okay, so we will be having a start push button, cycle on. So when cycle is on, motor one is on. Okay, and similarly moving to second one, motor two on. So when cycle on, motor one on. After that, we are going to have a on delay timer. After 5 seconds, motor 2 should get on. And similarly, for motor 3, we'll have cycle on, motor 2 on, and there will be a on delay timer. After 5 seconds, motor 3 should on. Okay, so in this way, we implement the sequential logic in order to prevent the power supply. Okay, so in order to prevent the power supply power, we go for running a motor one after the another. Okay, thank you.